We use them every single day. But have you ever really stopped to think about what's going on inside that computer on your desk or in your pocket? Well, today we're going to do just that. We're going to take a guided tour and dissect the anatomy of your machine to see how all its different parts tick.
So here's our game plan. We'll start with the absolute basics. Then we'll get into the good stuff, the computer's brain, its memory, how it senses the world, and finally, the very soul that brings the whole thing to life. All right, let's jump right into section 1. What is the computer? I mean, it's easy to think of it as just a magic box that does what we want, but it's really a brilliantly designed, logical system.
And that brings us to the big question, the one that's at the heart of this whole thing. How do a bunch of physical components, wires, silicon chips, circuits, come together to do things that feel, well, intelligent?
Okay, the formal definition actually gives us our first big clue. At its core, a computer is a machine that does 4 things. It accepts data, stores it, processes it, and then spits out something useful we call information. And this whole process relies on 2 key parts that have to work together perfectly. First up, you've got the hardware. This is easy. Think of it as the computer's physical body. It's everything you can literally touch: the screen, the keyboard, and all those complex guts hidden inside the case. But, a body isn't much use without a mind telling it what to do. And that's exactly where software comes in. Software is the set of instructions, the programs, that tell the hardware what to do and how to do it. Honestly, without software, a computer is just a very expensive paperweight. So the real magic, if you want to call it that, is how these 2 things, the hardware and the software, interact. To really understand that dance, we're going to use an analogy for the rest of this tour: the anatomy of a living thing, and how a computer's different organs work together to form a complete system. So let's get right into that anatomy, and we've got to start with the most critical organ of all, the brain. For a computer, that's the CPU, or the central processing unit. I really like this quote because it just nails it. The CPU's main job is to interpret and carry out every single instruction you give it. And a key part of the CPU, the control unit, is like the ultimate supervisor, or maybe a traffic cop, making sure every command gets done exactly when and how it's supposed to. So how does it do this? Well, it's a constant 4-step dance called the instruction cycle. First, it fetches an instruction from memory. Then, it decodes that instruction to figure out what it means. Next, a part called the arithmetic logic unit executes the command. It does the math. And finally, it stores the result. Fetch, decode, execute, store. Over and over and over again. This is the basic heartbeat of all computing. And the speed is it's staggering. Take a look at this. A 3 gigahertz CPU can perform that entire 4-step cycle 3 billion times, every single second. That incredible speed is what makes everything we do on a computer feel instant. Okay, so the brain is processing things at a lightning pace. But where does it get those instructions from in the first place? And where does it put the results? Well, that brings us to the next part of our anatomy lesson, the computer's memory. The best way to think about this is to compare it to our own memory. You have what you're actively thinking about right now. That's your short-term, working memory. And then you have everything you've ever learned, which is filed away for later. A computer works the same way. RAM is its working memory. It's like a super fast workbench for all the programs that are currently running. But when you turn the power off, that workbench gets wiped clean. That's why you need storage, like a hard drive. That's the permanent warehouse where all your files and data are kept safe and sound, even with no power. So we have a brain and we have memory, but to be useful, our computer needs to be able to interact with the outside world, right? It needs senses. So let's look at the input and output devices that let it do just that. This is pretty straightforward. This is how the computer senses the world around it. We give it information with input devices, like a keyboard or a mouse or a microphone, and it shares information back to us with output devices, like the monitor you're looking at or the speakers you're listening through. These are basically the computer's eyes, ears, and voice. Okay, so we've covered the body, the brain, the memory, and the senses. But what's the one thing that brings it all together, that makes it a single, working, cohesive machine? Well, that would be the operating system, what I like to call the soul of the machine. The operating system, or OS, is the master coordinator.
is this incredibly important layer of software that sits on top of the hardware. It manages everything, the CPU, the memory, all those devices, and it gives you a simple interface to interact with it all, so you don't have to speak the computer's crazy complex language yourself.
And look, the OS has a massive job. This chart breaks it down into 4 of its biggest roles. It manages memory, deciding what gets to be on that RAM workbench. It manages processes, telling the CPU what to work on next. It manages all your files in the storage warehouse. And of course, it provides the user interface that you click and tap on all day. It's really the invisible director of the entire show.
So when you put it all together, you can see it's not really magic at all. It's this incredible symphony: the lightning-fast brain, the 2-part memory system, the sensory inputs and outputs, and that coordinating soul of the OS. They all work together in concert to create these powerful thinking machines that we rely on so much.
And that leaves us with one final big question. What we've just looked at is the anatomy of a computer today. But with technologies like artificial intelligence and quantum computing advancing so quickly, what will this anatomy evolve into? What will the brain, the memory, and maybe even the soul of tomorrow's machines actually look like?